Hi there, Matthew Laskaj here from Project Engineering Management Limited, and thank you for joining us. It's great to have your company, and I'm really excited today because we're doing a Q&A session. No slides, no pre-rehearsed presentations, just a relaxed discussion about something I'm really keen on talking more about, and it's 3D printing or additive manufacturing, and manufacturing in general. So today I'm really pleased to be able to present our special guest. His name's Andy Simpson. He's the director for Angus 3D Solutions and Manufacturing. We're coming to you from sunny Scotland. I'm in Aberdeen, and I guess 30 miles about south of Aberdeen is Brecon, Andy, where your office and manufacturing facilities are. So first off, welcome and thank you very much for joining us.
Matthew, thanks very much for the invite. It's great to be part of this new venture for you and taking your courses in the online. So thanks for the invitation.
Oh, great. So as we said, today's session, we're going to do something a little bit different where we're not going to provide any slides. It's just going to be all a chat. We're going to have a relaxed talk about 3D printing, manufacturing, engineering, and some of the processes and things that are happening in the industry, and just talk about some of your experiences in that. Question and answer session for those who have joined in. So thank you for those who have joined us for the session, and you'll get an opportunity at the end to ask any questions and have a chat with us. So before we get started, there's a question that I sort of like to ask everyone in interviews these days, and it revolves around, what do you clean the most at the moment? Would it be your house, your office, or your car?
Okay, just now it's definitely the office, even a wee bit quieter, so absolutely, giving us an opportunity to clear up these to-do lists and areas around the office where you say, yeah, you keep putting it off to one side. So yeah, definitely the office. Younger days, it would have been the car. My wife would say the house never.
No, exactly.
But occasionally when I do, she usually just steps aside because I can be a bit of a whirlwind. But,
and it's even more challenging when it's your home office. Then you've got to.
Well, yeah.
Yeah. So on to the topic, I guess, then of 3D printing or additive manufacturing. I tend to throw the two terminologies around a bit, but they are the same thing for those who are sort of new to that industry. Additive manufacturing is adding layer by layer to the manufacturing process, as opposed to machining, which is removing material or subtractive. So we've got additive manufacturing versus subtractive manufacturing. And I guess you do a bit of both where you are now, sort of getting into, because they do work hand in hand. But even though it's been around for a long time, it started sort of in the mid-80s, it's really blossomed or taken off, I guess, in the last 10 or 15 years in particular. And then the last 3 or 4 years, it's really sort of this buzzword, this catchword about, you look at what the industries are, but what made you decide to start up a business in additive manufacturing or manufacturing in general, especially with the times that we've got over the last 5 or so years? It must have been a tough decision to get into.
Yeah, absolutely. It wasn't an easy decision where to start up any business when there's a bit of a recession and that going on. My background is traditional manufacturing for nearly 40 years. It would have been easier and probably more logical just to start up a traditional machine shop. However, there's a lot of good machine shops out there already. When there was a recession on, what could I offer? I couldn't offer anything more or different than that was already available. It would just have come down to pure cost. So in a previous employment, I was looking at additive manufacturing for that company, and really that was all knocked on the head when the oil and gas downturn happened. So I decided that to get control over my own destiny, and start up my own business, the best way would be is to offer something slightly different, and it was in additive manufacturing. So that was why Angus 3D Solutions was formed, was from that. is really just trying to offer something different. What I also found was that, you know, in Scotland, we're a little bit behind on additive manufacturing, okay, than where maybe even down in England or in Europe. So there was an opportunity there of growth as well.
Yeah.
And secondly is that I could see the benefits of the technology to industries in Scotland. So part of it was to make people aware of it, you know, to make people aware of the technologies and how it could benefit them, and hopefully be able to encourage, you know, more manufacturing within Scotland in particular. So that's really how it all came about.
Yeah, I mean, it's good because, you know, they're starting to build up things like the manufacturing research centres and the national manufacturing centres and things like that. But you mentioned there about benefits to people, and you know, you think that there's not much take up at the moment of the 3D printing. When I speak to most people about 3D printing, they think of little plastic gimmicky toys, or they think of the, you know, the real high tech industries like Formula One or fighter jets, or, you know, those sorts of things. But I think a lot of people don't seem to see where it fits in between of those two areas. So how can it benefit? You know, you talk about manufacturing. How can it benefit that sort of industry?
I mean, you're absolutely spot on, Matthew. You know, it's seen as two extremes: cheap and cheerful, really expensive. You know, so we've got the cheap and cheerful tends to be, people see it as a hobby. It's a hobby machine, etc. And don't get me wrong, that has got its place, absolutely.
Well, I've got one and it's great fun.
Absolutely, no, absolutely. And in fact, let's touch on to that. It's a double-edged sword, that the hobby, right? Because what happened in the early days with 3D printing is that there was this big publicity about the benefits that it could bring, and then people went out and bought typically very cheap FDM machines in the early days.
Yeah.
And expectations were higher than what the technology could actually deliver. So there was a bit of a bad press where, when people were looking at it as a serious manufacturing option, going, this technology isn't going to do it. It's not going to make it. However, now as the technology has improved and people are becoming more aware of it, you know, and machines have come cheaper, etc., materials have got better, then obviously the standard has increased and now people are taking it more serious. So the hobby market has got a place, because where I see that is, that's if you can get a smaller FDM machine into your workplace or into somebody's home, and they start learning about the technology, they're not long saying, okay, this is what we could do with it. And it gives them that introduction into the technology, which then allows them to start developing stuff for the more industrial side.
Yeah.
So it's a very good place to,
okay,
particularly in an engineering environment, getting a 3D printer into an engineering department, and then somebody getting trained up on it, all of a sudden, you know, the engineers will be around that printer going, okay, we could do this, we could do that. It fuels that creativity, and then now people find more uses of using that technology. Then you go to the other extreme. I call it the sexy industries. Right? People, it's only for the sexy stuff, the Formula One teams, the aerospace and space technology and automotive. Okay? And a lot of people go, oh, I'm not in any of them, so this technology is not for me. It's wrong. Okay, the technology is there. The problem is that publicity and development has been done all around these industries, and that's purely because they've engaged it quickly, and secondly, they've invested in the technology. So when it comes to the 3D printer and the material manufacturers, they have built machines and developed materials around the industries. Okay, and that's why they lead the way. So when it comes to other industries, you're running them all general manufacturing. How can this technology help? Well, it's just another tool in the toolbox. maybe be used, or where I see a lot of the benefits is it's being used to support traditional manufacturing as well. Okay, so when it comes to getting your concept ideas, prototypes done, we all know about that, the advantages that this technology can bring in that area. If you do that, then it means when you move the product onto traditional manufacturing, the design's better, there's less issues in manufacturing, etc.
Yeah.
So there's some benefit. Other benefits is in things like jigs, tooling, fixtures. Okay, if you're making jigs, tools, and fixtures on your traditional manufacturing, that's costing you downtime because you're not using the spindles to produce a selling component.
Yeah.
Using jigs, fixtures, and tooling, where you can produce them very quickly and tend to be cheaper as well, in that area is where some of this technology comes in. And there's a lot more machine shops now bringing in 3D printing, not to produce end component, but using it for support to help them through the traditional. So I often talk about direct manufacturing and indirect manufacturing. Direct manufacturing being as I 3D print this component and that goes into my product, or indirect, I 3D print this product, but it doesn't go into my end product, it helps me to produce my product in another method, so it's indirect and support. So that's really where now in industry we've got to look at saying, how does this technology can help us do what we do today quicker, cheaper, and better, but it may not necessarily be the end product, if that makes sense.
Yeah, absolutely. And I think it's probably going to take off more, like you said, alongside the machining and the milling and the casting or whatever to make the tools. Because if you're spending £5,000 for a set of tooling to make your cast parts, what if you get it wrong? You got to go and start all over again and buy another set of tooling and that. So, make your prototype tooling or prototype parts, make your tooling with your 3D printing, and then start, injection molding or whatever it is you're going to do.
That's maybe this is one of the things that's come out of the COVID-19 as a good example. Is face shields.
Yeah.
Is another way to look upon it is that the shields, you can't be injection molding for them. That's the way to go. It's the quickest, cheapest, and it's the best way, and it meets all the standards that are required. However, some companies started printing some, and that was purely driven to get instant capacity.
Yeah.
We can produce components very, very quickly from day one.
And the 3D models are getting sent out for free as well, so you're not even having to spend the time designing them.
The beauty with that is that you could get product out very, very quickly while you're getting the injection molding molds manufactured and getting that set up where there's a lag to get that produced. And then you switch off the 3D printing once you've got the injection molding. So I've worked with a few companies where they've taken that approach, where they've gone, I know I've got to wait 8 weeks to get injection molding parts manufactured. However, I could produce some parts tomorrow and get that out to my customer or get that out to market quicker. But that technology, the 3D print technology, is only getting used for that, to get that instant sprint capacity while they're waiting for the other traditional manufacturing to kick in. So that some of that has happened with COVID-19 as well. As you're making masks, we're making visors. Unfortunately, some of them are not suitable for use, because they don't make standards. Okay, unfortunately.
No, so just then on that question, I mean, I saw the other day a promo for a new 3D printer, and I think it was saying it's the world's cheapest 3D printer. It's like $69 US for an FF or an FDM printer, and it's got you know, print bed size of 100 mil, 100 mil by 100 mil, so it's, you know, pretty small. But then you see all these videos and things of, oh, I'm printing visors for the NHS and I'm printing all this stuff, and I think there's a difference then between what you can practically print, not just limited by the size, but like you said, the quality. Just because you've printed a plastic something doesn't mean that it's going to be fit for use, does it?
No, exactly, and that's probably one of the risks with the technology, is that people's expectations could be higher than what they can achieve from the equipment they've bought. And certainly, just because you can print it doesn't mean you should be printing it.
Yeah.
Okay, so I mean, this is why we never printed, you know, Angus 3D Solutions, we never printed any visors, because it was, when I spoke to the government and the health service, they identified that some of them weren't going to be at standard, and to be perfectly honest, some visors and some health services have been packed up and sent to third world countries. They're not even being used, okay, because we have standards in this country.
So when you say they're not to standard, obviously they're made of plastic, PLA or ABS or something with an FDM printer. And how is one company printing with the same material good quality that can be used versus using my, you know, the one I've got in my garage? How is that any different?
It's just down to the level of technology. If you're spending several £100,000 on a machine and the materials for it against your £69 machine, then you know you're expecting a different level, and that's basically what it boils down to. Is that it tends to be that these more expensive machines have got additional parameters that you can control. The materials tend to be specially developed for that particular machine. As in, when you go to the lower level, it tends to be that, unfortunately, some of the materials are even, you know, substandard recycled materials that have been produced very cheaply, and when they're actually, you know, you think it's PLA or ABS, it's a mixture, okay, yeah. And then when you're burning that off, it's actually burning off toxic fumes at the same time.
Yeah.
So it's all about traceability, control of the process, control of materials, just as we see in traditional manufacturing, where, you know, in some industries, etc., oil and gas is a perfect example of that. Traceability, control, procedures, processes are a big focus. It's exactly the same in the medical industry as well. And unfortunately, just because you have a 3D printer doesn't mean you should be printing some stuff off.
Yeah, and if you're going to be printing little war games toys, be careful what you're printing in your bedroom.
Yeah, because unfortunately, yes, that is the challenge. Is there have been a few cases where some individuals are basically poisoning themselves in their bedroom.
Yeah. So you're mentioning, you know, the awareness of people thinking of what they are. Do you think that's the biggest challenge for it becoming more popular in the industry, that people aren't really aware of all those things you already mentioned? You know, they think it's, you know, the 200 or 300 pound printers, kind of I see that as like the bottom price you'd probably pay for a decent-ish, you know, to get something printed. You wouldn't want to go much less than sort of 300 pounds. So you've got a lot of people buying that £300 to £500 range of PLA printers. You know, there's lots coming out already now, and crowdsourcing and all these ones are bringing out new ones. And then you've got the £10,000 version, which is still the same materials almost, but technologies in that. Do you think that that's the main barrier for industry, is they don't understand how to go from £300 printer which prints that versus spending a huge amount of money on it? Where does their business fit in? Do you think that's the biggest blocker?
Yeah, it is one of the challenges. Definitely one of the challenges is understanding. It's like any asset that you're going to buy. Okay, if you're buying a traditional lathe or milling machine, what are you going to be using it for, and what is the standard that you're looking for? You don't buy you don't buy a £3 million printer, 3D printer for metals, when you know you don't need the standards that Rolls-Royce needs. Okay, you produce that type of component, so you don't spend that type of money on that. asset or investment. So don't get me wrong, like anything else, it's like buying a car, you know. I don't know, let's just pick on a Ford Fiesta as a great car, but it's absolutely useless on a Formula One track. Formula One car is the high end of, you know, car manufacturing. It's a brilliant car, but it's absolutely useless for going for your weekly shopping. So they've all got their place, and 3D printing is very much like that as well. Is that the technology has all got its different, because there's several different technologies under the banner of 3D printing. So again, is that you have some different processes to identify and choose, as well as, you know, the picking the right materials or choosing the right machine to use. So yeah, it's always going to be a challenge to a certain extent, of what machine, what material, what process that you're going to choose and what you're going to actually use it for. Mm-hmm.
Just when you said that, I just saw again the other day, there was when you're saying that you can't, you know, you don't want to buy a Ford Fiesta to drive in a Formula One team, and comparing that to 3D printers. I saw someone has converted a Honda Civic, I think it was, and they've made it do 0 to 60 in 1.1 seconds.
I did see that.
Can you do sort of supercharge your 3D printer if you do go for a lower end one? Say you spend £500 or £1,000 on one. Is there things you can do to make them better, or do you pretty much need to buy them off the shelf for what you want?
No, there's definitely people out there that, yeah, they'll hack them, and don't get me wrong, that a lot of the 3D printing companies, you know, that you'll buy a machine and they have opened up the software and they have opened up the parameters so that you can make changes, etc. And again, that's what encourages innovation, is that ability to go in and, you know, not be kept within a box where I'm going to say, I'm going to try something, and like anything else, the best inventions or the best ideas come out of usually a failure. You know, that didn't work, but my goodness, we've learned something from that. What if we do this, or what if we change that?
Yeah.
So there is, on 3D printing, especially on the cheaper end of the market, you will have that flexibility. When you come to the more expensive machines, it tends to be, there's a little bit more IP restrictions, etc. So the manufacturers can hold that back or control a certain element of the technology.
Okay, I've got two last questions before I let you off the hook. The first one, I guess, is we were talking a bit about the hobby, sort of the area, and that if someone was wanting to sort of get into it themselves, you know, where do you think that they would be starting? So I personally don't think you know, $69 printer is the first printer you want to be buying, because it's going to probably be challenging. But you know, do you think it's just go and buy something that's reasonably good and just have a go at it, or what would your advice for that be?
It depends if it's an individual or a company. Okay.
An individual, just
it's an individual. Yeah, I mean, again, go online, do a bit of research. There's plenty of forums out there. There's plenty of people giving advice on what's good, bad, and indifferent. What do you want to do it for? You know, if it's to support another hobby that you've got, you know, so like in the war games where people are printing off figures and things like that, depending on the level of detail you want, well, that will drive the level or the type of technology that you want to select. It will then drive the materials then that will drive the cost.
Yeah.
Okay? So it really just depends on what you're looking for. But yeah, you know, it's what your budget can afford. But again, it's just being very mindful that your expectations and your budget have to be aligned.
Yes, exactly.
Yeah. However, if you buy a 3D printer and you're using it, one thing you are doing is you're learning. You're learning more about the technology, and it's the quickest way of learning about the technology.
You definitely learn fast, don't you?
You learn fast, and again, a lot of that is down to failures. You will have bad prints.
Yes,
that is guaranteed. And But as you have these bad prints, you're going to learn all the time, and you go in and you make changes and you do things differently. You set it up completely different, and by doing that, you learn more and more about the technology, and then you're able to then say, okay, I need to upgrade my printer because I want to go and explore this aspect of it and make it something bigger, better, or whatever it may be.
Yeah. So yeah, one word of advice for people on that one is don't print with a PLA printer in your garage in the middle of winter with the door open and an unheated print bed.
And again, that's a great example, Matthew. Is that I had that with ABS when I first started out. I was printing off a part and it was printing very well, but I was printing overnight, and every morning I came in and the prints were split. And so I reset it the next night and did the same again, and it was exactly the same result. And then I realised it was exactly the same sort of height. And really, what it boiled down to is that it was roughly about 5 o'clock every morning where the temperatures changed outside and in the workshop.
Right.
There was a drastic change in the temperature, and that's why the prints were failing. It was purely because of that temperature change in the building. So yeah,
I've got plenty of Christmas prints with nice warped bases in the winter.
Yeah, good.
So on the other end of that, then you know, the decent quality printers that people are going to need for engineering and manufacturing industries, you know, are in the thousands, tens of thousands, and most manufacturing companies aren't going to want to spend that kind of capital, and they also need the expertise in designing them. You know, it's not just as simple as, oh, here's a model of a bracket, let's load it onto my printer and print it. So if you weren't wanting to spend the money on this big investment because you weren't quite sure yet, and you possibly didn't have the in-house expertise of a full-time person, how can those sort of businesses sort of benefit, or what would they do?
Well, from an industry point, regardless what you're doing, I honestly think, is that don't rush out and buy, okay? Is that I often have conversations with companies where they say, yes, we're looking to think about purchasing a 3D printer, and I'll help them choose that printer. But they'll be looking and saying, okay, the engineers want to be able to do this. The marketing department want to be able to do that.
Yeah.
And somebody else is wanting to do something else. And you're going, well, this one printer can't do all these three. Okay, you have to buy 3 printers then.
Yeah, exactly.
That's not going to happen, So what you want to do is if you identify exactly what you're going to be using it for and what you need, because that will drive that.
Excellent.
And then go out and speak to people, and and again, it's companies like yourself where we've done this with a customer before, where we've actually produced parts on our printers before they go and buy that printer, because they want to basically trial that material out. They want to trial the printer out, they want to trial out the process. So really, I've actually done that for them, where we've printed off the parts, we've got all the setup for them, we've done the paying, and then they've had the confidence in going and saying, well, this printer, this material, etc., does what we actually wanted to do and achieve, and then they go out and buy the printer. Okay?
Yeah.
We've done that a few times with people, is that, and to be honest with you, if you go to a printer supplier, they should be offering that service for you, as being able to print parts off to prove out the machine before you buy. I would definitely recommend going out to a bureau or somebody like yourself first and try it out to make sure you're happy with the results and it can do what is meeting your expectations before you go and spend a huge amount of money on bringing the technology. I'll be honest with you, I have actually going into quite a few places where the conversation has been, yes, we have got a 3D printer, and it's the most expensive ornament in this corner of the room.
Like that Lance Armstrong exercise bike that you decided to buy, not you, but people decided to buy, and it ends up being a clothes horse.
Yeah, and unfortunately, technology is that if it's left to sit in a corner, okay, and it's not used, they can be temperamental. Okay, the printers, they like to be used. They perform better if they're being used on a regular basis. Yeah.
Brilliant. Well, thank you very much. I think that was a pretty good whirlwind tour of a whole wide range of different topics, you know, sort of going all over with both ends of the spectrum. But I think, as you said, I don't, you know, even though it has been a buzzword over the last few years in particular, and it seems to be like people are sort of going, oh, that thing again. It's going to have its place, and I don't think it's even really taken off yet. I think once people start realizing what you've just said, that don't just think of it as making parts, think of it as an addition to your industry already, or your capabilities, and use it to build on what you already do. I think then it's going to sort of have another wave of becoming big, isn't it?
Yeah, I mean, it is. I know the technology was in the 80s, okay? Again, by accident, it was, you know, sort of developed from that. But think about it as in the way of CNC machines. The earliest NC machine was in I think it was the late 30s, early 40s, okay?
Yeah.
And that technology is, and even today, you know, we've stretched that technology to a point where we just add access to more and more access to the machine, and now we've got machines that have now 3D printers basically bolted onto them. But so we've taken that technology from the early 40s to today, but we've done as much as we possibly can with it.
Yeah.
Well, 3D printing, just starting in the 80s to now, we've got a huge length of time yet still to develop that, and that technology is developing a lot. And as more and more people use it and more industries adopt it, then the makers and the material manufacturers, they will obviously develop machines for particular industries, and so there's a huge amount of growth and potential there. So yes, we may not be able to print off a particular component in a particular material to meet a particular standard today. I can guarantee you, if the want is there, it will be developed and it will be there, and really, you know, in years to come, we've got this prediction 2027 is that 3D printing will be as common as a lathe or a milling machine in a manufacturing facility.
Yeah, brilliant. I think that's probably a good point to finish up on. As I said at the start, it was today's session was about just having a talk about, you know, see where it leads and what we'll have a talk about. But we've got some people obviously on the line as well, and if there's any questions from those people who have joined us, I'm going to throw it open to see if anyone's got anything that they want to ask you while they've got a captive audience. So if there's anybody who's tuned in, now's your chance to get Andy while you've got him cornered.
Hi Andy. Yeah, my question's around standards, because you mentioned that, you know, when you were talking about this rapid response to making visors, standards decided or helped us decide whether stuff was good or bad. And one of the things I remember being talked about maybe a few years ago in terms of 3D printing was that a lot of the current standards then in industries were written around traditional manufacturing methods and weren't actually recognizing the difference in 3D printing and therefore were inhibiting the adoption of technology. Is that starting to change now, or to what extent is that still a difficulty that you face, trying to get the best out of the technology?
Yeah, that's a good, absolutely spot on, Harvey. It's still a challenge, okay? It is changing, okay? It definitely is changing. They're making progress. You know, yeah, standards were originally driven around traditional manufacturing because that was what was available. And then you're trying to horseshoe a new technology into these standards. That's very, very difficult to do. However, when you've got industries like the aerospace, etc., that have spent a huge amount of time investing in that, is that, you know, they've developed basically developed the procedures, etc., for the technology, but for that industry. Okay, so what you're doing is you're basically bringing the technology, rewriting it into the terminology and language that industry is used to. So if you move to industries like commonly the oil and gas industry, it's a lot more difficult because the standards aren't written, okay, even in the additive manufacturing world, with the lingo or the terminology that the oil and gas are used to. So that is changing. That's definitely being worked on, and there is, you know, I think we've got 5 design procedures now, standards now for additive manufacturing in the industry, and there's about 15 now out for materials and processes, etc. So it is coming, but again, is it the need has to be there, or the want needs to be there before people will invest the money to go and develop the procedures, etc. It's coming, definitely it's coming, but it is still one of the challenges that we face today. Yeah.
Good question. And it is one of the things that sort of, again, is inhibiting people getting in, you know, businesses getting into it, because they don't think it's, you know, that's not qualified for use or something, isn't it? So
yeah,
great, thank you. Does it, anything else there, Harvey, while you're still there?
Yeah, no, absolutely. You know, because I guess my other thought around this, the whole thing about, you know, everybody who's got a printer printing visors has clearly raised the profile of the technology. And I guess my question is overall, do you think that's going to be helpful or unhelpful, given some of the cautions that you put in?
There's nothing better than publicity, is there? Especially in technology, this absolutely. You know, is it? You know, you're hoping people go, okay, this is serious technology for a serious issue. So when you align that two technologies with a serious issue, then there's a lot of credibility there. You know, so yes, it definitely helped. You know, and this is just my personal view. Is just that my concern is that, you know, and it is very much a personal thing, is that, you know, allowing or the ability to just produce items out of your bedroom and then go and supply that to people that are in life-threatening situations, you know, and not have proper standards in place, that's a concern, okay? Where the technology is great and it's got its place, however, in the wrong hands, it could also be dangerous. And that's where COVID, and I know I'm actually been invited to participate in a group where there's been some funding from the government to look into that, where if we were ever faced with something like this in the future, is how can we plug that very quickly, where we can adopt, we're not just talking about 3D printing, we're talking about any technology or any industry to switch over to medical very, very quickly and understand or be guided through the requirements that's needed. Okay, and that could be as a permanent or a temporary thing. I mean, temporary is that, yes, you can 3D print off these parts, but they all have to be 3D printed off with only for use in COVID-19. Okay, so that we know that they're not meeting the standard, but they're only getting used in a particular application.
Yeah. Okay, brilliant. Thanks, yeah. Andy.
Thanks very much, Harvey. I think it was a valid point, and one of the earliest versions of that, I suppose, was the weapons, when, you know, people were trying to design guns and things. You know, good examples of them blowing up in people's hands. It put some people off from being a little bit more ambitious, but brilliant. Yeah. Any other questions from anybody before we let Andy run away?
Not necessarily a question, Matthew, just to say thank you for a very informative webinar, really.
Great, excellent.
Yeah.
Thank you, Rob.
No problem.
Right, well then, I think if that's all we've got. Thank you very much for everybody joining in. It was nice to have some other questions and other points of interest in that. So that was brilliant. Thank you, everybody. And especially thank you for Andy Simpson from Angus 3D Solutions. You know, to speak to somebody who does this as a living and is seeing what's going on, especially when we're also just seeing the news and what's happening around the world via media. It's good to get sort of an inside view of somebody who's dealing with these sorts of things all the time and speaking to the customers and seeing, you know, what are the needs of what we're doing in engineering and manufacturing. So thank you very much, Andy.
My pleasure. Thank you.
Good. Well, and so thank you everybody else as well. So yeah, hopefully we could, if we haven't scared you off, we can have you back and talk a little bit more about what's happening shortly once things are starting to move on, maybe with the virus, and we're starting to open up things back in the manufacturing world.
Okay.
All right. Thank you, Andy. Thanks everyone, and see you all soon.
Thank you. Bye now.